So I am Sarah Novotny, and I work for Nginx. I'm also program chair for O'Reilly Media's OzCon. But my love is open source. So Nginx pays the bills, so I get to talk about them a little bit too. But Nginx is a open source web server, load balancer, proxy server, reverse proxy server cache, and SSL termination tool set. You've probably run across it. It's most commonly compared to Apache, but does a whole pile more beyond that. We also fit really neatly in the microservices architecture. So as I talk very broadly about microservices, you'll occasionally see little Nginx logos pop up. I am happy to talk more about Nginx because, as I said, they pay my bills. But I also have sat in your shoes, sat in your seats before and don't particularly enjoy the talks that end up being too heavy on vendor pitches. So if you have questions about Nginx or Nginx Plus, stop me. I'm happy to answer them. I'm happy to dig in further. But I'm going to talk more broadly about microservices and the cultural changes that need to come with it. So it doesn't matter what you build as a developer, no matter how awesome it is on your laptop, on your local area network, in your head, in your specification diagrams, where you actually make the difference, make the change, is getting it out to your users. And so finding the most efficient and fast way to send your application, to get it delivered to your end users, is really where your value is made. So this speaks to some of the DevOps revolution as well, making sure that you as a developer are also happy to support and manage and engage with and improve the end user experience. So web performance functionally is user experience. It doesn't matter what you can do locally. That doesn't work anymore. How many people get those still every day? It's terrible. I can't find my network. I can't do it. 20 almost years ago, we used to talk about the 10-second rule. If you couldn't load a web page in 10 seconds, your users were going away. I worked long ago at a bookstore, and we talked a lot about getting that first above the fold page to load in 10 seconds. 2001, it was more like 8 seconds. Anybody want to guess how low it goes today? Instantaneous 1 second. It's pretty close. The last study I could find was 2010, which said 3 seconds. But it basically also said that for every additional second, you lose more than 7% of your conversion. And when Obama changed his front page, back when he was soliciting campaign donations in the earlier campaigns, when he changed his front page to load 60% faster, he saw an immediate return of 14% increased donations. So this is information that you guys need to know and need to live and love. On phishing pages is the other option. We all used to see these. Sorry, I'm doing something. Not right now. Come back later. And that really is not something the user finds acceptable anymore. So microservices as an architecture presumes one thing. It's not going to go well. Technology is going to break. So if you build with microservices, you are able to iterate faster, embrace failure, and change the way you deliver your experience to your end users. So functionally, embracing failure means knowing that things are going to break, knowing how they're going to break, knowing how you're going to behave when they break, and how you are able to change them and how quickly you are able to change them. Speed is not just end delivery. I focused on getting the first bytes to the client. I focused on getting the first page above the fold to render, but it's not just that. It's your content delivery for sure. And that's one of the things that is most directly measurable for an end user, for a website, for how to interact with something. but it's also feature delivery. How quickly can you make changes? How quickly can you get new features out to market? How quickly can you as a business differentiate from your competitors? And digital delivery is one of those spaces that is table stakes for a presence, and then table stakes now for evolution and differentiation. Defect resolution is another speed that needs to be considered. How quickly, when something is broken, can you fix it? Twitter took 9 months, 12 months to get over the fail whale all the time, and that's not really something that our users are all that happy about. Now, there are certainly cases where we were talking about sort of hype curves in Docker before this. There are certainly technologies and certainly websites and certainly experiences that your user will forgive bad experiences on, but not your average business, not your average website. You see that with that additional second, with moving to a 4-second or a 6-second delivery. Some of the statistics I saw said 40% of the people that come to your page, your website, your interaction, or your application will abandon, and then 80% of those that abandon will never return. And that's not something you need. So defect resolution, product nimbleness, changing and being able to adapt to your marketplace. This is all about speed. And speed functionally needs tight feedback loops. So who's heard of the OODA loop? This is going to be really, no, yay. Okay, let me teach you the OODA loop. It is a military theory. It's observe, orient, decide, act. And you do this over and over and over. And it's iteratively fixing and changing what we see. What is going on here in this conversation? Several of you are nodding, several of you are engaged. Ooh, you might not be engaged. Interesting. I need to observe, orient myself for this, make a decision to change my presentation, not change my presentation, and then move on and act. You do this constantly. It's a tight, tight feedback loop. And this applies to business just as well and technology just as well as it does the military ideal, the battlefield experience. So we've got speed being all about tight feedback loops and making sure that you know where you are, you know what is going on around you, choosing and acting as quickly as you can and being able to make these changes. This goes back to that speed. In order to have that speed, you need clear agreements. How many of you have, say, change control processes and large-scale meetings before deploying code? And do any of you still? Come on. Some of you do, okay. How many of you are doing continuous deploy at this point, like 11 times a second or 4 times a day? You also do that. You have big meetings and you deploy several times a day. Okay, so you've got all the options. Okay. How many of you are not going to tell me what you do because you might get picked on? Okay, everybody else, good. All right, so these clear agreements allow for different pieces of an organization to move more quickly. This is functionally looking at code and changing it. To go back to the military analogy, military is all command and control. Except that it isn't, especially if communications break down. So it's all command and control, and then if there is someone in the highest position of authority who cannot reach the next person up the chain, they have to make a decision, make a change, and move. So these clear agreements, these clear contracts are what allow individual pieces of software, individual pieces of an organization to move more quickly. So the monolithic architecture is not really about fast. Is anybody going to disagree with me on that? No. Okay. You commit code, it may touch something that nobody's looked at in 10 years, and then you don't know how that's going to affect 3 other things that somebody hasn't touched. And this is all packaged up and deployed, or packaged up and then built and compiled and deployed in some sort of massive, maybe virtualization, if we're lucky. Certainly not often containers, sometimes off to hardware that we're not sure what has changed on that recently. And this monolithic architecture is slow, it's lumbering. And you don't have clear agreements within the code unless the libraries are particularly well abstracted. But even then, there's sometimes the undocumented library or the I don't know what's over in that corner, but if we change it, this other thing over there breaks. So the monolithic architecture is really not built for speed. It was built for durability, ostensibly stability, and a command and control structure. To scale within this, you need to scale the whole thing. To change, you need to change something in one place that may affect many other places. These services are also frequently, they're by definition written in the same language, the same framework, and you end up having this historical baggage of a language that can last within your environment 3 years, 5 years, 10 years. Making changes to one service means building, compiling. How many people go through things like staging, UAT, testing, UAT, deployment off of your own laptop? This is, again, not fast. You change one thing, you have to rebuild the entirety of it, test it soup to nuts, and deploy it. What if somebody on the left side of the room broke something and somebody on the right side of the room is trying to fix something that's live on the site right now? But my build's broken. I can't. These are all lagging and slowing and weighty pieces within monolithic architecture that make it not what we need today in business to differentiate. If other services have bugs, you have to wait for them to be fixed. These are all the examples, and release cycles tend to be long. How many people have made Gantt charts to explain when we're going to deploy something? How many of you still have to? None of you? Fantastic. Why are you here? Really? That's awesome. Okay, monoliths still tend to be very tightly coupled, low trust, and have cascading failures. This functionally means things are very slow. So how do you get from monolith to microservices? Who wants to get from monolith to microservices? I presume if you came to this talk, you have some inkling that you want to move toward microservices and what the benefits might be. Your game, all right, thank you. He's gonna raise his hand for everything. This is awesome. The rest of you, nap time? What? So how do we get there? How do we refactor? How do we have a monolith and get to the magical containers and rainbows of the future? It's not as difficult, nor does it have to be greenfield, as one might imagine. So the microservices architecture is functionally dividing things by micro application, microservice, oddly enough. You want to take a functional piece of code, a functional piece or a function of a business, and turn it into a piece of code that is independent, that has clear contracts and clear agreements around it. Boundaries that are APIs, boundaries that are documentations. Ideally, boundaries that are interrogable, so you can ask it what it knows, what it does, and how it behaves. This is RESTful APIs. You don't have to start with a greenfield architecture. When you go to touch this monolith in a space that has, say, a change that needs to be made, you can see if there is an abstractable business function that you can pull out. So I need to go update identity management. We're going to move from LDAP to Google Applications and Google's OAuth. Okay, normally, you'd build that right back into the code base. It would break 100 different things, and you would have to figure out how to work that through the business process. If you go ahead and look at this from a microservices architecture space, you can abstract out that service. You say, I'm going to make an authentication service, and that authentication service begins as its own unit. Then you make changes to the monolith to speak to the authentication service, and you peel out piece by piece as you can the independent services, They can be written in different languages. Each service then becomes its own build, becomes its own deploy, becomes its own, or begins as its own group, and can be iterated much more rapidly as long as you're staying within the bounds of that contract, the API boundaries. In this case, it's an example of to-dos, calculations, and copies. Super simple, broken out this way. Microservices makes continuous delivery far more possible. Monoliths are much harder to deploy. There are companies who do continuous deployment and continuous integration of monoliths. There's a lot written by Etsy about the positive sides of monoliths and how microservices is all hype. And like everything else in tech, we are having a fad of microservices. Everyone called it SOA 10 years ago, and it's not that different, minus the microservices bus. Sorry, the enterprise service bus. It is something that we move to where it fits. There is no actual silver bullet. If any and all of you have worked in tech long enough, you know that it doesn't matter what I tell you up here. If it doesn't fit in your environment, in your architecture, or in your culture, it's not going to work. The things that make microservices positive are some of the same things that make microservices a challenge. You increase the complexity. You increase the speed of delivery. You increase the independence of the developers. You presume that you increase the communications between them, but that's a whole bigger cultural conversation. Continuous delivery, rapid deployment, and elasticity of the environment. But what really enables the microservices architecture? It's a lot of automation. It's an enormous amount of automation. It's making sure that those contracts I speak of, the API contracts, are tested automatically with every build. It's automation of deployment. It's automation of testing. It is very loose coupling between the different services. You are always speaking to another group's tooling through their API. There was a great paper, rant probably, by Steve Yegi about 5 years ago. He worked at Amazon in the early 2000s and then went on to Google. And he wrote a rant, which you can actually look up, Steve Yegi's Google platform rant, if I remember correctly, on Google. And you'll get a fantastic article about how Amazon, by culturally enforcing that every group spoke to each other through APIs and services, allowed them to move away from a much more fragile, much more highly coupled system. Even though it wasn't a monolith, the two-pizza team edict, and so no team can ever be more than the size of who can consume 2 pizzas, or which could consume 2 pizzas, and every different service group working together and interacting with each other through APIs and services allowed them to move very much faster, and actually was the underpinnings for what has become AWS. So instead of compiling in another group's library, or making use of and linking into someone else's binary, you went ahead and spoke through APIs. So this loose coupling and the strong contracts between these organizations allowed them to move much faster and build more pieces of their infrastructure as products. So as soon as the website team stopped having to interact with the deployment team in the same way, and the deployment team made everything available through an API, out pops EC2. You have a new product because of this separation and this loose coupling. So it's also, I say, high trust through contracts. It's also a low trust environment that is enforced through SLAs. These contracts have service level agreements attached to them. So I'm building an authentication service. My authentication service needs to be available all the time, or you can't log in. Okay, this is great. What happens when you can't log in? What are the failure points? What are the failure cases? What can I, as a service consumer, expect from this failure? And this is where the Simian Army, which is one of my favorite open source projects, comes in. Netflix, open source, one of the very early adopters of microservice architectures in the cloud version, not in the SOA version. We'll separate those slightly. Built a set of tools. Have many of you heard of the Simian Army? Yes? No? Some? Okay, so I'll go over it a little bit. Yes, some? You built it? Is that what you said? No. Oh, you're right. Okay, good. Thank you. It's an interactive audience now. Yay. So the Simian Army is a set of open source tools that help you presume and simulate failures in a microservices architecture. Chaos Monkey is perhaps the most well-known tooling. And Chaos Monkey goes out and occasionally knocks over EC2 instances. So, oops, what happens when that service's EC2 instance falls over? Was it redundant? Did it have a fallback plan? Did it meet your contract SLA for the API? Did you have a way to handle your request if it failed? So who gets awakened when the Chaos Monkey goes out and actually introduces chaos into your environment? They've gone on and added a whole great number of other tools to the suite, things that add latency, because of course we know that things breaking completely is very different from things breaking kind of. That's an entirely different experience. But these Simian Army assaults are something that within microservices are very important. The failure cases are just as important as the success cases, making sure you understand how your tooling works with other microservices when it fails, and when it fails in unusual, unexpected, different ways, which is why to another point of the test-driven development, you end up writing more tests. You find new ways that it can fail. And this is all supporting APIs as contracts. Continuous integration and continuous deployment are a part of this as well. If our goal is speed, if our goal is speed to resolution, speed to product change, speed to the end user, then we want to be making changes in as safe a manner possible through these strong contracts, through these tests, and deploying them as rapidly as possible in order to make things better, ostensibly, for our users. Feature flags are another great piece of this. What happens if something isn't working? What happens if you can't authenticate? Well, you can still do some things on a website or on an application without authenticating. You might not be able to change your settings, but you should still be able to say browse content. So what happens when some piece fails? The Simian Army gives you an example, but you can also turn things on and off. I know that my recommendation service is very slow right now. So I'm going to turn that feature off, and the end user never has to see it. The aggregation of the front end of a mobile application or a website can just literally make those failure points vanish, closing up that space in a front page. And how many of you would ever notice if Amazon's gold box deal of the day wasn't on the front page? Any of you? I wouldn't. But it's a service. There are almost 200 services that compose to make the front page of Amazon today. If 20 of them were gone, I bet a very small number of us would notice. I can still browse the website, I can still look through all the books, I can still do searches, but I won't know what my friends purchased. Okay, would I actually notice that if I'm just going to go look up a book and try and send the link to a friend? Probably not. And that makes for a better user experience, which is fundamentally what I'm arguing microservices gives you when done properly, is faster speed to the user, faster speed to resolution, and faster and more seamless failures, more graceful failures. So feature flags can turn things on and off. You can also dark launch a feature. I want to go ahead and put something out into production, run it on under the normal load conditions, but not actually show the end users. This is great. It's a feature flag. It's still out there. The code's in production. It's playing. We see how it behaves, and yet nobody's using it, or only 10% of my users are using it. So I can see how it starts to perform under production load, and I can slowly ramp it up. These are all pieces of microservices that are great. But how do you go ahead and refactor that elephant that I suggested we were going to refactor it? I'm going to say the same way you do anything else, which is one byte at a time. You peel off the pieces, the services that you think you can, that need adjustment, that need changes, and say, how can I abstract this to a business level service? There's a lot of conversation about how big is too big, how little is too little. In the microservices, can I use the word wankery here? In the microservices thought leadership. That's the word I'll choose. And the answer is, it's whatever size fits your organization. For some people, this might mean you take your monolith and you make it 2 monoliths, but one side does something relating to catalog. My references are frequently bookstore related because I spent early years of my career there in operations. So it's a really great metaphor in a lot of cases because there are so many different pieces in it. And we all use it every day, so it makes it easier to describe. But maybe it's all about catalog, and maybe it's all about the user. And now you have 2 monoliths. Okay, it wouldn't necessarily be called microservices, but it could move you along the path toward what you need to do. I wouldn't recommend taking one single monolith and making 2, but you might take all of your user management and move it out instead of having a 100-line login service. There's also a lot of discussion about when to move from monolith to microservice. And like everything else in tech, the answer is it depends. It really is when your organization needs it, but please don't optimize too soon. It's the same problem as everything else. Should I put everything in the cloud and automate everything because I'm going to have 1 million users next Tuesday? Well, are you really going to have 1 million users next Tuesday? Do we really need that to auto scale to, infinity? If you're NASA and the Mars lander, yes, you know you're going to have 1 million users on Tuesday. Build it in that complicated a way. If you're playing with a new little service, you may not need to over-optimize at this point. So peeling off, yes? Mm-hmm.
What is different here? User service or login service or order service,
This is
shared, reusable code, so you don't bundle them together. They're always separate. I'm trying to understand.
Why is microservices?
I'm sorry,
No. The answer is, I don't know that there is anything that much more special. So just for starters, I will admit that it is a new name with an evolution of architectural ideas. So the biggest change between something like a service-oriented architecture and a microservices architecture is the lack of the enterprise service bus as the back-end communication for everything. It's also the idea and the tooling now, 5 years, 10 years, 15 years on, that allows us to do more federated and distributed data storage. So you're storing your data more close to the application as opposed to in a single back-end relational database. So you have, Netflix has a great example. They actually use and wrote their own data service that makes sure that even though the microservices are using data in a very denormalized way, it goes through and eventually makes sure it's consistent. Now, this is not in the sense of non-relational databases where you have a cluster of, not a cluster of machines, a set of machines that has a quorum to decide how your data is served to you or what the right answer is. But this is in the sense that I might have a Redis store, and I might have a Memcache store, and I might have the canonical user record in a relational database. And eventually, I need to make sure that all of these different data records are consistent. So moving to an allowance for a denormalized data set and having data closer to the microservice or the service is one of the big changes within within the service-oriented architecture and microservices change. But you're right, it's frosting on the service-oriented architecture cake, but it gives us vendors something to talk about.
I can give you an example.
Oh, good.
So we have this big monolith with 150 services that different partners are using. Every time that we change a service or a partner, we have to redeploy the application. So it makes sense to split it in, let's say we have 60 partners into 60 separate services. So when I'm deploying for partner X in Finland, I'm not breaking the application for the Chinese partner. Okay.
Does that give you enough of a grounding?
Sure, I've heard examples like that.
Mm-hmm.
I don't think to be, wow, I'm so special, but
Mm.
I mean, I've been writing services and they're standalone. We make RESTful calls
Yep.
against them, and yeah, the service changes, the app. I still need to test my app if the service changes.
Right?
You don't have to test everything. Pardon? You don't have to test everything because it's a monolith. When you're changing one service, you have the potential to break any other service. Oh, I agree. I'm not disputing it. But if I don't have that monolith, does that mean I've been doing microservices all along?
That's what I was just about to suggest, is you may have been much closer to microservices than you thought. So, yes?
Your point on message bus,
Mhm.
that's not to say that a message bus is anti-microservice,
No,
right?
it's-
In fact, having more microservices might be a time where you might need to introduce
A message bus. That is certainly a possibility.
We don't talk explicitly about message bus, but that
Right.
doesn't mean it's anti-microservice to use message bus.
Right. And there are a lot of analogies drawn between MuleSoft and the message bus, because MuleSoft is an integration point for lots of software as a service tool sets, existing APIs. It's a nice, clean integration point. And so there's a lot of comparisons in that way. I would say microservices, as I said, is sort of frosting on the SOA cake with a few changes that just are natural architectural evolutions.
Where it makes sense now because of the big monolith is because we're paying IBM by JVM, so it makes sense to bundle as much as possible in one JVM. Now with container is cheap, you can have bundles.
You're making my point. This is awesome. So these services scale independently. So instead of writing, my search service in Java because everything else is written in Java, I might have 3 guys who really want to do something in Go. Actually, I have no idea if Go is a good language to do search in, but let's presume it is for a moment. And they want to build their search, they want to build this new search service and pull it out of the monolith and build it in something that doesn't require a third-party middleware application server or is built in a lighter weight way. So you have pieces that scale on the heavier hardware or virtual machines or application servers, and then other services that scale in a much more lightweight way on containers or in virtual machines even potentially, but they don't require that application layer. So you're able to scale more granularly with the tool set that is necessary for the application or the service that you're looking at. Now, all this said, I did mention that that many of these benefits with microservices are drawbacks, because we've just added a whole pile of complexity. Everybody wrote everything in Java 5 years ago. Now I've just said that 3 guys want to go off and learn Go. So now I've got to figure out how to integrate that as a process and a culture in my organization. So those 3 guys go off and write a service. In this case, it's the plus service up there. They're peeling it out of the monolith. And they are going ahead and building out this first microservice. They're finding a way to scale this piece that they think is a good business unit, business service, and has clearly defined boundaries on it. Well, that's great. And they build it, and they start to deploy it, and they've got all of their tests, and they've got all of their continuous integration and everything. And I said that we needed the OODA loop. So we've got Culturally speaking, when you're trying to break up a monolith into microservices, you have a lot of challenges. Usually it's a small team that's asked to go pull one piece out, and that team can be perceived as elite or chosen or getting to do the cool stuff, and everybody else is still stuck doing Java. So this is another one of those spots where the tight feedback loop is very important, both from an architectural and a computing and operational standpoint, but also from a cultural standpoint. Because if this is seen as just a privilege, then you can end up with large rifts in the organization. But if you use this OODA loop, this observing, orienting, deciding, and acting, you don't want to act before you decide, that's backwards. OODA loop, you can build a culture of learning as well. So you are observing, you are orienting, you are deciding, you are acting. I would put in another D there, which is documenting and teaching. So making sure that as you're going through this evolution, you are actually increasing the amount of communication between your teams initially until you've gone through the cultural change. And potentially even long-term, because you still have those very tight contracts. You have very big lessons learned in very small groups, which the entire organization can benefit from. So making sure that this feedback loop of communication among the people exists is just as important as this feedback loop operationally and this feedback loop programmatically. Learning organizations, building a learning organization, changing to a learning organization is hard work. It's going to be as hard or harder than making your code changes. And especially in large-scale enterprises, shifting this mindset from I have feature delivery, I have operational stability as my siloed and divided goals, and finding alignment of those goals is functionally what DevOps is about. Now, I've seen a lot of enterprises say, we have dev and we have ops. What we really need is DevOps. And that doesn't actually help. I mean, it sort of starts to bridge the gap. But that tiger team, that little team that goes out and breaks out, say, that first microservice and then takes on call for it because it's so different from everything else and manages it and tries to teach and share everything that they've learned is the beginning of the DevOps culture in an organization. And the more you feed that back into the rest of the organization, the more accountability and responsibility and alignment of interests you have around that feature delivery, user experience, and operational stability all together. So organizational change is hard. It's really going to be the bigger step in this than refrosting our SOA by removing a bus. So now we can move to a space where we've got 3 little teams building out 3 little services in my very pretty diagram. And they are all talking to each other. In this picture, we still have a back-end database as its primary store, and this is, again, that first potential step of evolution. We haven't denormalized the data. We haven't said we're going to pull data closer to the application. But that's a whole nother chunk of microservices, which can be tied to public and private cloud containerization and modern web architecture. And that's data gravity, because you have to put your compute where your data is at this point. So if you are starting to break apart this database, you end up having a lot of options of moving these services nearer to the data and making them faster for these reasons. And this all happens through these very clear agreements, making sure you know where your data is, what the canonical source is, how it gets changed, and how it gets eventually consistent. And making sure that this cleanup happens and is watched, because of course you have to have something watching the watcher. This goes back to good operational process. These clear agreements, these interfaces between and among all of these little pockets of microservice are clear boundaries And the clearer the boundary and the more self-documenting it is, again, this is RESTful for you, in this space, the easier it is to maintain and scale from pulling out a single microservice to a dozen microservices to the world of Amazon's front page, which has close to 200. Netflix has something on the order of 300 microservices. And this all gets tested with, I spoke about the Simian army for a moment before. This all gets tested by introducing failure on purpose. And these independently scaling services, you can lose one node from them, you can lose a piece of them, you can lose the entire service, and you can, in fact, lose, you can have it fail and lose in non-traditional, non-binary ways. I talked a bit about that already as well. These services scaling independently allow you to fix and eliminate and alleviate some of the pain points, but when they fail, they may fail in very unexpected ways, which is why you do this on purpose. So I've been talking a bit about Amazon's front page and what works and doesn't work and how it fails and how it succeeds. These are examples of specific services within Amazon and how they each load and render, are queried as services through APIs and then pulled together and composed to make a front page or a web application in order to give you the different views that you need at any given time. But as I said, if one of them fails, you lose some portion of the functionality, but your user isn't turned away that it's not available, never to come back. I did say there'd be little ends that showed up here, so I'll give you the why we care about this. So Nginx is, how many of you use Nginx? 1, 2, 3, a couple, sometimes, okay. So Nginx began 10 years ago as an open source project whose sole purpose was to enable 10,000 concurrent connections on 2002 hardware. So I see a phone there and another phone over there. That's roughly a 2002 server right there in your pocket. So can you get 10,000 concurrent web connections on your phone easily? With Nginx you can. Hey, well done, thank you. We do have an ARM build. So Nginx was built 10 years ago because Apache couldn't do that. You couldn't get 10,000 concurrent connections on a piece of 2002 hardware in any sort of meaningful way. It was built to be fundamentally different from Apache in that it was built with an event-based architecture instead of a process-based architecture. So every connection that comes into Nginx does not spawn a new process, taking up new memory and CPU and all of that, which is the Apache model. Well, I won't say even currently. They have since added an event model in their architecture as well. But for the most part, when you throw an Apache server up, it spawns a new process every time there's a new connection in. And every HTTP connection in HTTP 1 and 1.1 ends up using keep alives. And those keep alives mean that you have lots of connections open. So I might be browsing Amazon's front page, and I'm not going to do anything for 5 or 6 seconds because I'm human and I'm reading it, and I'm not a computer. But those 5 or 6 seconds still keep open a connection to the server, which uses processor and memory and keeps this load on the server in an Apache model. So Nginx was built to have 10,000 concurrent connections on 2002 hardware. We can actually do, with proper kernel tuning now, better than 1 million concurrent connections on a piece of hardware. Now, mind you, I said with a lot of kernel tuning. So your eyebrows went up. It's a lot of kernel tuning, because you run out of file descriptors well before that. It's ugly. But Nginx has broadened from that original goal of a reverse proxy server and web server for static assets to also include load balancing and caching and additional SSL termination. So we function as that front-end application delivery application delivery layer in front of your and with your application. So if you have a Java application that's running in JBoss, Nginx can act in the front end as the cache. So even with things like services that are relatively dynamic. We give a great example of a WordPress website. It's relatively dynamic. It's usually a pile of MySQL queries to load any page. Even if we put 1 second caching in front of the WordPress server, we can see 10 and 20 and 100 times increases in performance by moving away that heavy lifting of HTTP and keep alive work, as well as doing little bits of caching and taking the work out of the application server. So that's functionally what Nginx can do in the very broadest sense. Load balancing is another big component of what we do, and that's how it fits into the microservices architecture. Load balancing, front-end routing, URL-based routing, URL-based rewriting. This is where it comes in particularly with microservices, I want application 1 to go over here. It's going to be a little Go service. I want application 2 to go over here because somebody wrote something in Node. I want my very different application to happen. This is still part of the monolith. It goes out to the great big JBoss server. So you can use Nginx as that. I used the description in the Docker talk earlier this week, the stevedores, the people who are loading the containers and going out and sending the traffic to the right application, sending the traffic to the right server, the right service, and potentially even interacting with that in terms of rewriting, changing URLs, moving traffic, using varying load balancing algorithms to determine where the traffic actually goes. So Nginx behaves as this giant shock absorber in front of your applications. And it handles great big spikes in traffic because it's event-based. We have one master process and then the number of worker processes that match your cores. It's generally the auto-config setup. So you'll have 4 or 8 or 128 cores and that many worker processes. But the master process is doing all of the handing out of the work. But you don't have to have a process open for every connection.
But if you're running virtualization,
You can't match to physical cores, but you can still tune with best estimates and figure out where you need to. That's totally just, you can have virtualized cores as well. And that it works almost as well in the sense of the tuning process. You're very close with an estimate against the virtual cores. With containers, it's a little bit different too, yeah.
Let's say you have a service.
Mm-hmm.
The goal is to also have services that can communicate with each other.
Yep.
So Nginx can help in a multiplexer. It can help take a bunch of sleepy connections and only have the working ones in the process.
Mm-hmm.
But what happens when you have a working process, an application process that needs to make an asynchronous call?
Mm-hmm.
Another one. Are you does that process, does it have to handle the asynchronous input outputs itself, or can Nginx help with that?
You guys are just teeing up questions for me. This is awesome. That is a very new feature for us, is an asynchronous I/O threading for Linux. Now, it happens by default, or no, there is by. This gets a little bit further into the inner workings, the specifics of it, than I have good facility with, but we did add threads specifically for asynchronous I/O in Linux. You don't need to use it with FreeBSD, if I'm remembering correctly, because that has it by nature in its kernel. So there's a blog post on nginx.com about this that got a whole bunch of traffic recently because we just posted it. It came out in the 1.9 release, which is our mainline release, which was released here in April. So you can read more about it there.
But can, because this seems to be like a proactive pattern, but my question is when an application microservice and then sits idle, how can you make it accept another connection from Nginx?
So that ends up happening because the master process is the one that is doing the accepting of the connections and then sending them out to the worker processes.
Yes.
And then the worker processes, if they end up needing to do something asynchronous, although we may be asking a different question, or I may be answering a different question, in which case I'm sorry.
Yes.
Okay. Okay. Then I'm not sure I understand the question well enough to answer it.
Well, okay, let's say we have a fast CGI process.
Yep.
So you have Nginx, you have 5 connections and 2 fast CGI processes. So at the point, those 2 processes will accept the connections and will do some work. And then we'll call, for example, 2 other microservices each.
Right.
And in that meantime, they don't have to work.
The upstream.
They accept other connections. So if we do a synchronous call, it makes the application very easy. But if we want to have it in a asynchronous mode, does the process have to handle the reactor pattern itself, or can it rely on Nginx for outgoing connections?
I believe it can rely on Nginx because Nginx is doing this as event queues internally. So it is waiting for the answer back. And so we don't actually work within the PHP application. So it will go out to a PHP FPM or a PHP app server. Whatever happens there, the worker will be waiting but not blocked for whatever is coming back from the PHP application. Does that answer it?
Well, wouldn't one of the 2 fast CGI connections still be blocked?
Yes. The fast CGI connection would be blocked because that is the application layer that is, so this is why we act as that, as preferably a proxy and a cache for that. So we would ask less often and be able to serve out of caches for most of or as much of the traffic as we could instead of overloading the CGI processes.
So that means if a process needs to communicate with other microservices, since I guess it's the point of having
A pile.
microservice architecture,
Yep.
those processes would have to handle the reactor pattern themselves.
If they are in the CGI application, then yes. Yeah.
And I guess that's one of the cons of working with microservices architectures.
Yep.
It brings a lot of complexity when you want to have few processes and be able to keep the state.
Yep.
And they make other calls to other microservices.
Yeah. All of the things that are,
Services don't quite mix very well.
which, stateful and micro? Yeah, state and microservices is that starts to get messy.
Sometimes you need to be able to have state
Absolutely.
services.
Yep. And sometimes you figure out ways to stash state temporarily places.
Suggestions for that?
No, outside of my skill set, fortunately. I just know you can do it. It's above my pay grade. So let me go back to the varying places that we can exist. So in front of the application servers, but you're right, it doesn't actually change the limitations of the application server application. It sits in front and gives you that shock absorber as opposed to changing how it actually works internally. Also, so we've got application server, we've got API interfaces, API management layers, so you can do things like rate limiting to make sure that your CGI service doesn't get overloaded. You can actually use Nginx to rate limit that space. You can use it for things like SSL termination authentication. You can do SSL authentication all the way through to the backend proxied host as well. So we have certificates and authentication all the way back to the proxied host. And generally, as the pieces and the interlocking glue of microservices, because primarily the idea behind microservices, although not exclusively, has been APIs, HTTP services. They certainly can be WebSocket services. They certainly can be TCP services, and Nginx works with all of those as well. So do you have any further questions? Because I'm landing right here on we're the shock absorber of the internet, right there. And then, and we have a book that we sponsored about microservices. So that's the first 5 chapters as a preview at that bit.ly URL. Anybody else? Yes, questions, and I'll go to you next. Okay.
I know this is probably slightly biased, but Nginx versus HA proxy,
Mhm.
is there room in the data for both? Does one shine better than the other? And you guys say, what's up with HA proxy? Don't need that, just use Nginx?
Right. So the answer is, because I wear my open source hat for these things, there's room for both of them. We do different things better. And so there are cases where HA proxy is a better choice. There are cases where Nginx is a better choice. And we are happy to work with them. We have little baby Twitter wars teasing each other. You know, it's open source. We want there to be choices for people and for people to be able to choose the best tool. What the finer points of when one is better than the other is I think we have a blog post on that, although it's still hard to write that kind of thing because you don't want to throw stones. Your question, yes?
So, let's say we're running on something like Kubernetes.
Yep.
And every time a new plug comes up, you have to reconfigure our Nginx.
Yes.
Learn about it.
Oh, my goodness, you guys are giving me such awesome questions.
So, I know about the template configuration file.
Yep.
But is there a better way?
There is, but you'll have to pay for it. So my open source hat now comes off. So Nginx still pays my bills, and we have a tool called Nginx Plus, which is the Nginx open source software with plus all sorts of other things that we think are important. One of them is a automatic configuration API. So you can go in and say, I have a new service that needs to be added to this upstream. I have a new service that needs to be changed. It also gives you more granular monitoring, deep health checking, better ways to manage your cache so you don't have to just dump an entire cache and invalidate an entire cache, so you can be more granular about it. It also has additional load balancing algorithms and that sort of thing. So we're trying to add the nice to haves in Nginx Plus and keeping the core performance, scalability, reliability in the open source tooling. It is not really REST. It is REST-like. How about that? It is HTTP. It is REST-like. We have not gotten as far as making it interrogable for all of its information and that. But it's pretty well documented, and because I get to further the pitch, we have support and services that we'd be happy to help you with if you have any trouble. Oh, and I'm getting the timeout sign. So thank you so much. Yeah, thank you all.